The universe is growing, and not just a little bit. It's expanding at a scale that's almost impossible to imagine. Every second the fabric of space itself stretches, carrying galaxies farther and farther apart. But where is it really going? Why does it look like everything is rushing away from us, like we're somehow the center of everything? Here's the wild part. Space itself is stretching out, and that might mean we're on a collision course with a cosmic ending. The more we learn, the more we realize how little we truly know about our place in this ever-expanding cosmos. Let's rewind about 100 years. Back then, the idea that the universe could be changing at all was almost unthinkable. Most scientists believed the cosmos was static and eternal, unchanging through the ages. Astronomer Edwin Hubble, up on Mount Wilson, peered through his telescope and shattered what we thought we knew. His observations would forever alter our understanding of the universe. What he saw was mind-blowing. Nearly every galaxy was moving away from us. The universe, it turned out, was not a still painting but a dynamic, ever-changing masterpiece. We weren't in the center. The universe itself was changing shape. No matter where you are, every observer sees the same thing. Galaxies receding in all directions. So, what was Hubble actually seeing? What was the secret hidden in those faint, distant smudges of light? When light travels from those distant galaxies, it stretches as space expands. This is called redshift. The farther the light has to travel, the more it gets stretched, like a cosmic rubber band being pulled. It's like when an ambulance zooms past and the siren drops in pitch as it moves away. That change in sound is the Doppler effect, and light does something similar as galaxies move away from us. Only here, light waves are stretching out, shifting toward the red end of the spectrum. This redshift is the universe's way of telling us it's getting bigger, and the farther away a galaxy, the faster it appears to be moving. This relationship is now known as Hubble's law, and it's one of the most important discoveries in astronomy. Hubble's discovery was our first real proof that the universe is expanding. It was a turning point, opening up a whole new way of thinking about the cosmos and our place within it. But what does expanding mean? Is everything just flying apart, or is something deeper happening to the very fabric of reality? Picture a balloon covered in little dots. Each dot is like a galaxy, and the balloon itself is space. As you blow it up, the dots move farther apart, not because they're crawling over the balloon, but because the balloon surface is stretching. No matter which dot you stand on, all the others seem to move away from you. That's what's happening to our universe. Space itself is expanding, and everything in it is being carried along for the ride. Galaxies aren't rocketing through space, they're being carried by space itself as it stretches out. The distances between them grow, even though they're not moving through space in the usual sense. Now here's the twist. This expansion isn't slowing down. In fact, it's doing the opposite, it's actually speeding up. The universe is accelerating, and that's one of the biggest mysteries in modern science. That's thanks to something called dark energy, a mysterious force making up almost 70% of the universe. We can't see it, touch it, or even fully explain it, but its effects are everywhere. Scientists aren't sure what it is, but dark energy is literally reshaping the fate of everything. It's as if the universe has a hidden engine, pushing it to expand faster and faster, rewriting the future with every passing moment. So, how does the story end? What's the ultimate fate of all this cosmic expansion? Some predict the Big Freeze, where everything drifts so far apart that the universe becomes cold and dark. Stars burn out, galaxies fade, and all that's left is a vast, silent emptiness. Others imagine a big crunch where gravity pulls everything back together. The universe could collapse in on itself, ending in a spectacular reversal of the Big Bang. Or the Big Rip, where space stretches so fast it rips galaxies, and even atoms apart. In this scenario, not even the smallest particles are safe from the relentless expansion. Our universe is racing into the unknown, changing every second. The future is unwritten, and the possibilities are as vast as space itself. But does it even have an edge? Is there a boundary, or does space go on forever, beyond what we can see or even imagine? Next time, we'll explore the mind-bending nature of space and time. Think time travel, gravity, and warped realities. Are you ready to journey even deeper into the mysteries of the cosmos? Subscribe and activate the stars. Don't miss the next space-time adventure. The universe is waiting.